In this video, we will be converting rectangular coordinates to polar coordinates, and here's the formula that we will need. R is equal to the square root of x squared plus y squared, and tan theta is equal to y divided by x, and x cannot equal 0. So let's explain these two formulas. So for the first formula, you can kind of think this is x and this is y, and we have a 90-degree triangle, 90 degree right here. So we know that x squared plus y squared is equal to r squared. Then we take the square root of both sides, and that's how we get this. Next, how do we get this? So tan theta is equal to opposite y divided by adjacent x. And x cannot equal 0 because you can't divide by 0. Now we will solve one problem together, and this is a problem that we will solve. Convert the rectangular coordinate 3, 3 square root of 3 to polar coordinates. And so if you want to pause the video and attempt this problem, feel free. So the first step is to identify our x and our y value. So x is equal to 3 and y is equal to 3 square root of 3. Next, we can solve for r. So r is equal to the square root of 3 squared plus parentheses 3 square root of 3 squared. So 3 squared is 9, and then 3 square root of 3 would give us 27 because 3 times 3 is 9. 9 times 3 is 27. And so we would get the square root of 36, which is 6. So next, we need to get our theta. So tan theta is equal to y divided by x. And so we just swap. So y is 3 square root of 3 divided by x, and x is 3. So now we can simplify a little bit. So we can say that tan theta is equal to the square root of 3. Then we take the inverse. So theta is equal to tan inverse, the square root of 3. And now we need to think, we have 3, 3 square root of 3. So we are in the first quadrant. Because we are in the first quadrant, tan inverse of square root of 3 would be pi 3 or 60 degrees. And so our polar coordinates will be 6, 60 degrees or 6, pi divided by 3, depending if you want to go with degrees or radians. And that's pretty much it for this video.